Hey, good morning, everybody. This is Mr. Ainsworth, and we're going to get into a quick little lesson here on how to graph inequalities, given in slope-intercept form here. Okay, one of the prerequisite skills that are needed here to understand the lesson here is how to test a point in either an inequality or an equation. Okay, so let's go over through a basic skill here of how to test a point. So let's take negative 2 comma 5. All right, the x coordinate is negative 2 and the y coordinate is 5, and let's test it, okay? And to do that, all you do is substitute it into the equation and determine if you have a true statement or not, okay? So you substitute the point in, do the equation, all right, and see if you have a true statement. All right, so x is negative 2 and y is 5. So let's get started. Okay, so the question is 5 less than or equal to, all right, 2 times x, which is negative 2, all right, plus 1. It's actually quite simple. You just test it and see if it's a true statement. All right, so let's simplify. Okay, 2 times negative 2 is negative 4. So is 5 less than or equal to negative 4 plus 1? I don't know. Let's check. Okay, negative 4 plus 1 is negative 3. So 5 is less than negative 3, and this is false. Let me put it over here. False. All right, and that tells me that negative 2 comma 5 is not a solution. So let's state it. Let's be specific here, okay? Is not, all right, a solution. Now, if it was true, if it ended up being a true statement, well, then I would say it is a solution, okay? So that's what false means. You can't just say false, true, or false. You got to tell me what it means. All right, and right here it says, or I ask you to determine whether it is whether it is or not a solution. Okay, so you got to tell me what true or false means. Let's do it a few more times because we're going to do that here in inequalities. So is negative 3 times the x value, negative 2, plus 4 times y, which is 5, is that greater than 1? Question mark. Okay. Well, negative 3 times negative 2 is 6. 4 times 5 is 20. So you have 20 right here. 20 plus 6 is 26. And 26 is greater than 1. So this is true. So right here I can tell that the test point, negative 2 comma 5, is a solution. Okay, SOL solution. How about this one right here? Y is 5. So the question is 5, is that equal to negative 3 times negative 2 minus 2? Well, question, we got to simplify a little bit, right? So a negative times our negatives are positive. Okay, negative 3 times negative 2 is 6. 6 minus 2 is 4. 5 is not equal to 4, okay? So put a not equal to sign here. Actually, you know what? I'm going to just say false, okay? Okay, 5 is not equal to 4, so this is false. All right, so your test point, negative 2 comma 5, is not a solution to this equation either. Okay, and that's all you do is you substitute the point in and you simplify and you ask yourself, is it true or false? Piece of cake. Okay, so now what we're going to do is we're going to take that skill and we're going to apply it to inequalities here. And inequalities, or graphing inequalities, is similar to graphing linear equations, but there's a few added steps, okay? Because the solutions will lie off the line, okay? It is more than a line, and I'll verify that when I'm done, and I'll show you on this cool graphing program I have. So what we want to do is we want to take a look at the boundary line first, and the boundary line is nothing more than the same inequality with an equal sign, okay? So let's start graphing y is less than. Let's detail this out here. This is less than. Okay, let's take the inequality and write it as an equality. We call that the boundary line, okay? So y is equal to x divided by 3. X divided by 3 is 1/3 x. Okay, I'm going to write it like this instead, okay? Just put a 1 right there in front. You can see that the coefficient is 1/3. That's going to be the slope. All right, so it's important that you guys understand that x divided by 3 is the same thing as 1/3 times x plus 2. Okay, Now remember slope-intercept form. Y equals m times x plus b, right? Well, I can see that the slope is 1/3. I can see that the y-intercept is 2. Okay, so let's write down 1/3 for the slope and the y-intercept of 2. Okay, that's great. So now what we have to do is we have to graph the boundary line. Okay, and the slope, or excuse me, the y-intercept of 2 is actually at 0, 2. Okay, it's always on the y-axis. So you come up here on the y-axis, on the vertical axis right here, and you find 2, 0, 1, 2, and you plot a point right here. Easy, okay? You always plot this first. Then you take a look at the slope, and if you see a slope of 1/3, well, you're going to rise 1 and run 3 from the y-intercept. So put your pencil back at 2, and you're going to go up 1, and then write 3. 1, 2, 3. Repeat it. All right, up 1, write 3. Oh, there we go, right about there. Okay, and then go ahead and take your straight edge out. Use pencil now, okay, because something's weird's going to happen here, okay? Well, nothing too weird, but you're going to have to use pencil because what's going to happen is that you're going to find out that solutions are not on the boundary line on this one, okay? So the very first thing what we want to do is test the y-intercept. Is this a solution? So I'm going to use that as my first test point. So I'm going to rewrite the inequality right here. Y is less than 1/3 times x plus 2. And I want to test the origin, or excuse me, the y-intercept at 0, 2. So is 2 less than 1/3 times 0 plus 2. And anything times 0 is 0, so I get 2 is less than 2, which is false. Okay, now because of that, let me put my test point up top here. My test point was 0, 2. That tells me right here, this point right here is not a solution. And because of that, solutions don't lie on the line. So what we're going to have to do here is make it dotted. Okay, so get your eraser out and make it dotted, because in inequalities here, solutions may or may not be on the line. Okay, so we're always going to test the y-intercept, and we're going to understand that if we see either less than or greater than, the solution is not going to be on the line. So the question is, where are they? Are they above it in the upper half plane or below it on the lower half? Okay, so what we have to do is we have to test another point. Okay, and what I usually do is I test the origin. Okay, I always test this point right here, the origin. And the reason why is because that is the easiest test point to test. Okay, so we're going to test 0, 0 in inequality here. Both x and y are both 0. That's why we use it. So the question is 0 less than, excuse me, not y, but 0. We're going to put 0 in. 0 less than 1/3 times 0 plus 2. Well, that's 0, right? So we have 0 less than 2. Okay, 0 is less than 2. This is a true statement. Well, not 2, but true. Sorry. So that tells me that this is a solution. Now take a look at where it is. 0, 0 is below the line, right? It turns out that if you test any point below the line, it's also going to be solution. So your test point tells you which side of the boundary line the solutions lie. And since 0, 0 is below the line, we're going to shade below the line. Okay, all the solutions lie here. In fact, if you have a highlighter, do this right here. So they don't lie on the line, they lie below the line. So this is called the solution region. So these are much different than linear functions, okay? So if this was an equal sign and not a less than sign, then the solutions would just lie on the line and we would just draw the line. But when you either have less than or greater than, or even less than or equal to, the solutions are off the line, you guys. They're entire regions. I can test any point in here. All these points, an infinite set of points, all these points will satisfy this inequality. Okay? And it turns out that when you have less than, right here, this is less than, the solution or the boundary line will always be dotted. Okay? And if I see less than, it will always be below the boundary line. So dotted and below the boundary line. That comes from experience. So if you're wondering, how do I know that? Well, because I've graphed thousands and millions of these inequalities here. And I know that anytime I see less than or less than or equal to here, excuse me, less than, it will always be below, dotted and below the boundary line. Always. And let me make one little note clear. Okay, solutions are not on the boundary line. Solutions are not on the boundary line. BL for short, okay? Boundary lines or BL stands for boundary line. That's why it's dotted. If it was solid, they would be on the line. Okay, so let's get some experience. Let's do it again a few more times here so you can see it. One example is usually never enough, okay? And then right here, you switch from greater than to equals and you write your boundary line. So we have to graph first, y is equal to negative 3/4. Notice how I brought the negative up top, times x plus 1. So if you compare this to your slope-intercept form, and I always write it like this to compare, you'll see that the slope is negative 3/4 and the y-intercept is just 1. So negative 3/4 for the slope, which down 3, right 1, and the y-intercept 1 or 0, 1. So always plot these y-intercept first, always. So you plot here at 0, 1 on the y-axis, and then from here you go down 3, right 1 using the slope. Okay, so 1, 2, 3, 1, 2, 3 to the right 4, and you get your boundary line. If you want to reverse it, you go up 3, left 4. 1, 2, 3, 1, 2, 3, 4. And notice that you can plot more than one point. So you graph the boundary line. Okay, there it is. So you plot the y-intercept and then graph. All right, using the slope. So once again, here we go. Let's test our y-intercept here. So we're going to test 0, 1. X is 0, y is 1 into our inequality here. So here we go. We're going to test it always in the inequality. Okay. So was y greater than negative 3/4 times x plus 1? We got to figure that out. So y is 1. So we have 1. Is that greater than negative 3/4 times my x value plus 1? Well, that's 0. So is 1 greater than 1? And the answer is false. Okay, so 0, 1, okay, is not a solution. So get your eraser out again, and we have to make it dotted because the solutions are not on the line. Okay, so if they're not on the line, they either got to be above it in the upper half or below it on the lower half. Okay, let me make a little note here. Solutions, okay, are not on the boundary line. Okay, that's why it's dotted. That's what dotted means. Okay, that's how mathematicians tell where the solutions are. It's an easy way to do it. If it was solid, I would assume that they're on the line, okay? But they're not because 0, 1 is not a solution. It's greater than. This is greater than. Anytime I see that too, by the way, I know the solutions are not going to be on the boundary line. Only less than or equal to, if I see that equal to sign, will they be on the boundary line? That's how I can tell, by the way. Okay, so the question is, are they on the upper half or the lower half? So let's do another test point. Let's test the origin because this is the easiest point to test. Okay, so here we go. Test 0, 0. So we're going to put 0 in both locations. So is 0 greater than negative 3/4 times 0 plus 1? Well, that's 0. So the question is 0 greater than 1? And 0 is not greater than 1. Okay, that's false. All right, so our test point is not a solution. So this is not a solution here, and it's on the lower half. All right, so if the solutions don't exist below, they better exist above. So let's draw arrows above, indicating where the solution region is. Or you can get your highlighter out, and you can shade the upper half of the region. They're all up here. This is the solution region. So all the points up here, all these infinite set of points, every single one of them, they're all solutions. We could go on all day, all night, testing all these things. But if the solutions don't lie below, then they have to lie above. All right, I'll just do one more test point. I'll test this point right here. This is 1 comma 2. I'll just show you. So 1 comma 2. Here we go. X is 1, y is 2. So you substitute 2 in there. So it's 2 greater than negative 3/4 times 1 plus 1. Well, let me write that a little bit better. There we go. So 2 greater than negative 3/4 plus 1. Negative 3/4 times 1 is negative 3/4. Then you have to add 1 to get a fourth. So you end up with 2 greater than 1/4. And that's true. Okay, and if that's the solution right here, ooh, that's why it's in the solution region. Okay, so 1 comma 2 is a solution. And that's why it's in the solution region. And it's right here. Okay. So, a couple things. Let me say it again because you're getting used to this. If you see greater than, first of all, the boundary line is going to be dotted, okay? Because you don't see the equal to part on it, all right? And then also notice that it's shaded above. So I know by looking at the greater than symbol, I know that it's going to be a dotted boundary line, all right? And above, dotted and above. Just a little quick little insight right there. That's how mathematicians or your teachers know exactly whether you're on the right track or not, because they know these little things from experience. All right. Let's do one more. Let's do a less than or equal to. Okay, so y is less than or equal to negative x plus 1. So your boundary line is y equals negative 1 times x. Notice how I pulled the negative 1 out there. That's the coefficient. There's your slope plus 1. So my slope is negative 1. As a fraction, it looks like negative 1 over 1. Rise over run, right? So down 1, right 1. And the y-intercept is 1. There's your y-intercept, or 0, 1. So let's plot that here first. We always plot the y-intercept, as you guys already know. All right, and let's test it. Let's test it. Okay, so here we go. So test 0, 1. So we're going to put in x and 0 for x and 1 and for y. So is y, just look right here now, okay? 1 less than or equal to negative 1 times the x value is 0 plus 1. Is that true? I don't know. Let's simplify. So negative 1 times 0 is 0. And 1, is that less than or equal to 1? And the answer is yes, that's true. Okay? All right, so that tells me that 0, 1 is a solution. So now our y-intercept is a solution. Oh, I had to graph the equation here too, so I'm sorry. Got a little ahead of myself right there. So let's go down 1, right 1, down 1, right 1, down 1, right 1, and plot the line, okay? Sorry about that, guys. I should have done that in the beginning, okay? Use your pencil. Okay, so you graph your boundary line. Here it is right here. There's your boundary line. And we test it as 0, 1 because I got excited here. I wanted to test the intercept, the y-intercept right here. And I found that the y-intercept is a solution. Because of that, the boundary line is solid. Okay, solutions are on the boundary line. That's what it means. Solutions are on the boundary line. So we're not going to make it dotted. Why? Because solutions are on the boundary line. On the previous case, they weren't on the boundary line. Like up here on the example 2, 0, 1 was not a solution, so we had to make it dotted. Dotted boundary line. Remember that? Right here. But not here. Okay, so the question is, do the solutions lie in the upper half or the lower half? Okay, so let's test. Let's test the origin. Now the origin is below, so let's see if it's a solution or not. So I'll just use the area right here. So 0, 0, x is 0, y is 0. Got to put a 0 here and here. So is 0 less than or equal to negative 1 times 0 plus 1? Well, is 0 less than or equal to 1? And the answer is yes, it is. Okay, and that means that 0, 0 is a solution. N0 is coming 0. Where does it lie? Well, just look at the graph. It lies below, right? So all the solutions lie below. So you simply graph the or show the solution region below. Get out your highlighter, let's say, and just highlight it and say, hey, all the solutions are down here. This is the solution region. That means that all the points down here are solutions. Okay, let me show you this equation right here. I forgot to show you. Where to go? Where to go? Where to go? Here it is. There we go. Okay, so y is less than or equal to negative x plus 1. So let's graph this guy. So let me get my keyboard. Okay, here we go. So y is less than or equal to. I can't show you less than or equal to, but I can show you less than. Pretty sure. Let's see here. Y is less than. Okay. Where's my normal keyboard? You know what? I can't do that on this program here. So, you know what I'm going to do? I'm going to switch programs. So check this out. Your TI-84s that you guys have, I can do it too. So I'm going to switch programs because that's what we do. Is we improvise, we adapt. Okay. So check this out. So we're going to graph this equation on your TI-84 graphing calculator. All right. And so we have this right here. We go to the equation editor and we type in y1 is less than or equal to. Let's make this, let's change this here. Oh, how do we, let me see, I gotta remember how we do this. Is a new software here. I'm going to pause on this too. I got to remember how to do that on these new, my new graphing software. Slightly different than the old ones here. And my keyboard's not working here. So I'm going to pause on this and come back to that. So what I want you guys to do right now is turn on the back side. It's time to practice here. At this point, I want you guys to pause and play in the video here and do your best. And check your solutions with each other, and then of course you can try your homework in your textbook, which is right up here. Okay, I'm going to pause the video. I want you to try this next one here, and then when you're ready, go ahead and press play. Okay, so I'm going to assume that you were pausing and playing here and that you are done with example 4. Once again, I would like you to pause and play, all right, and check your work in this section here, simply because you got to practice it, right? All right, and then checking your work for quality is always important. Okay, so assuming that you already did number 4, so the boundary line looks like y equals 1/2 x plus 1. There's a 1 in front of the x here up here. Let me put it in red here so you can see it here. So the slope is not 1, it's not 2, it's actually 1/2. So there's your slope and there's your y-intercept. So the slope is 1/2, the y-intercept's 1 or 0, 1. You always plot the y-intercept first. So come up here at 0, 1. And then on your slope, you go up 1, right 2. So you go up 1, right 2, up 1, right 2, reverse it, down 1, left 2, down 1, left 2, and you go ahead and graph your line. Make sure you use pencil because sometimes the boundary lines are dotted. Like in this one right here, I can see that on y less than, if I see less than here, the boundary line is going to be dotted. And from experience, I'm going to say below too. And I'll show you why. So we're going to make it dotted. So you got to use your little eraser here. Okay, make it a dotted boundary line. All right, that means solutions are not on the line. Solutions are not on the boundary line. They're either on the lower half or the right or upper half. So test your origin, which is below. Real easy test point. So we're going to substitute in. So 0 less than, all right, 1/2 times 0 plus 1. And you get 0 less than 1, which is true. All right, so that tells me that 0, 0 is a solution here. And that tells me that all the solutions are below. So you got to shade below. The solution region is below the boundary line. So down here. Okay? And that's number 1. And if you got it, okay, then go on and try number 5. If you didn't, you got to fix it, right? All right, so pause the video again. And when you're ready, press play and check number 5. Okay, I'm going to assume that you're done. So now your boundary line looks like y equals -2/5 x minus 2. The slope's -2/5. That means down 2 right 5. The y-intercept here is -2, or 0, -2. And on this case right here, I have a greater than symbol, okay? It's called greater than. So I know I'm going to have a dotted boundary line, but I'm going to test it and prove it to you here in a minute. I know that it's going to be dotted and above, just by experience. But let me go ahead and graph. So 0, -2 first, going to graph the y-intercept. And then from there, I'm going to go down 2, right 5. So down 2, 1, 2, right 5. 1, 2, 3, 4, 5. Reverse it, up 2, left 5, and you're up here. Come on. So there you go, and get out your straight edge. All right, use a pencil, because sometimes the boundary lines are dotted. And then go ahead and test your point. So we're going to test 0, 0, -2. So x is 0, y is -2. So is -2 greater than -2/5 times 0 minus 2? So is -2 greater than -2? And the answer is no, it's not. This is false. All right, that tells me that 0, -2 is not a solution. All right, that tells me that the boundary line is dotted. That's what it tells me. And I knew that coming into it because it's greater than. So on greater than, I know the boundary lines are always dotted. So get out your pencil again and your eraser. All right, make it dotted. Okay, great. So the question is, are they above or below? So let's test 0, 0, which is up here above the boundary line. Here's your boundary line. So if 0, 0 is the solution, we shade above. If it's not, we shade on the other side. Okay, so let's test 0, 0. So 0 greater than -2/5 times 0 minus 2. Well, is 0 greater than -2? And the answer is yes, this is true. So that tells me that 0, 0 is a solution. So I got a shade up here. All these points above here, above the boundary line, are solutions. Or you just simply use your highlighter and say, hey, this is the solution region here. You get crazy. Okay? Okay, there you go. And there's number 5. Okay? Now pause the video and try number 6. Okay? Make sure you pause the video. Try it first and then press play. All right? Pause the video. Okay, I'm going to assume you're done. So here we go. So our boundary line looks like y equals -3/2 x plus 3, the slope of -3/2 and the y-intercept of 3. So we got -3/2 for your slope. That means down 3, right 2. You got a y-intercept of 3. It's right here, or 0, 3. So we plot 0, 3, and we go down 3, right 2, down 3, right 2. And you graph your line, your boundary line, that is. Okay, and always use pencil because if you don't know whether the boundary line is solid or dotted, well, you got to use a pencil, right? But right here, I see less than or equal to. So right here, I see less than or equal to. So I know the boundary line from experience is going to be solid. I'm going to predict that. Solid boundary line and less than or equal to and below. Solutions are going to be below. That's what I predict. All right, so let's figure it out. Let's test it. So we're going to test the origin, the y-intercept first. X is 0, y is 3 here. And we're going to say, hey, is 3 less than or equal to negative 3 halves times 0 plus 3? Well, is 3 less than or equal to 3? And the answer is yes, this is true. So that means that 0, 3 is a solution. And that means that we have a solid boundary line. Okay, so I'm not going to make it dotted. I'll make a solid. Why? Because solutions are on the boundary line. Solutions are on the boundary line. That's what this tells me. Okay. The question is, are they below or above? So let's use our famous test point, which is the origin. So when we test 0, 0, both x and y are both zeros. So let's do that. So is 0 less than or equal to negative 3 halves times 0 plus 3. Just look at your inequality up here. I'm always testing in the inequality. So that's 0. So is 0 less than or equal to 3? And the answer is yes. Okay, this is true. So that tells me that 0, 3 is a solution. So all my solutions lie below the boundary line. Okay, so get your highlighter, all right, and shade below. It's from the boundary line below. They lie on the boundary line, but also below the boundary line. Okay, not above, but below. So this is my solution region. Got a little crazy there with the red pen. I don't know what happened there. This is called my solution region. There we go. Okay, last one. Okay, until you get to jump into your textbook here, go ahead and pause the video one more time. All right, try number 7. Pause the video. Okay, you're back now. So let's go ahead and check your work. Y is equal to negative 1/4. Notice how I put the 1 in there. It looks like negative 1/4. There's your slope. X minus 2. There's your boundary line. So the slope is negative 1/4, which means down 1, right 2. The y-intercept is negative 2, or 0, negative 2. So we start there. Always start at the y-intercept. Always start here. And then from there, go down 1, right 4. So down 1, right 4. Reverse it. Up 1, left 4. Okay, and then go ahead and graph your line. And use pencil, of course. Okay, we're going to test 0, negative 2, our y-intercept. Now, I'm going to predict something. I'm going to predict for greater than or equal to, I'm going to predict a solid boundary line. All right, and above. The solutions are going to be above because of the greater than symbol. All right, let's make sure we make that happen. So here we go. X is 0, y is negative 2. So it's negative 2 greater than or equal to negative 1/4 times 0 minus 2. So is negative 2 greater than or equal to negative 2? And the answer is yes, this is true. So that tells me this is a solution. So that means that we have a solid boundary line here. Okay, so my prediction part of it was true so far. So solid boundary line. The next point we need to test is the origin, which is right up here. So 0, 0. If it's a solution, we shade above. If it's not a solution, we go in the lower half. Okay, so we're going to test 0, 0. So both x and y are both zeros. So we have 0 greater than or equal to negative 1/4 times 0 minus 2. So is 0 greater than or equal to negative 2? And the answer is yes. Okay, so this is true. That tells me that the origin is a solution. So where is it? It's above, right? Well, that means all the solutions are above. So we shade above. All right, get your highlighter out and do that. So all up here. All right. So there's a quick review and a quick lesson here on how to graph inequalities. Okay, their solutions are either they're off or on or off the line, first of all, and they lie in half the plane. Okay, all these points up here, they're all solutions, not below the boundary line, but above, because of the greater than symbol. All right, we call that the solution region. Okay, now this is a video, right? So what you guys can do is you can pause and play, and you can rewind, and you can go back and listen to anything you want here. Okay, there's a lot of testing with points involved, and after a while, you get the idea that hey, if you see less than, it's always going to be below. If you see greater than, the solutions are always going to be above. If you see less than or equal to, the solutions are always going to be on the line and below. So it's going to be solid and below. Little tricks like that help out. And if you'd like to, well, guess what? There's a little reading right here. It's a summary of everything I said written down right here. So you can read that too and refer to that if you like. It's kind of tough to remember everything I say. All right, so get out your textbook here. There's a class set. Do your homework in the book, and always do this in your spiral, as you guys know. And I'll see you in my next lesson, and we'll take a look at how to graph inequalities in standard form instead. All right, I'm out of here. This is Mr. Ainsworth. I'll see you later. Bye-bye.